Welcome everybody to the beginning of page 104 in the workbook. We are going to look at example 7 here. This is going to introduce a new piece of notation that's convenient when we're working with antiderivatives. Okay, so our discussion starts by asking kind of an interesting question. It would like us to list 3 different antiderivatives of the function 4x cubed. Now we probably already know one of those. X to the fourth certainly works because if we take its derivative, we get 4x cubed by the power rule. But what would another antiderivative be? That's kind of strange. You might think that there's only one antiderivative, but notice that if you add a constant to that, x to the fourth plus 1, that's also an antiderivative because of the fact that when you take the derivative of x to the fourth plus 1, you get 4x cubed. Okay, can you think of another antiderivative? How about x to the fourth plus 2? And what you realize is that you can add any constant that you want to the end of this, and we actually get an infinite collection of antiderivatives, one for every constant that you want to add to the end. And so we come then to the idea of what's known as the most general antiderivative, one function that kind of describes all of the one expression that kind of describes all of the antiderivatives at once. So in general, we could say that f of x equals x to the fourth plus any constant c is a way of representing every possible antiderivative at once. And this is what we call the most general antiderivative. Okay, and just point out that that c represents any constant. So that brings us to the definition that we're seeing down here at the bottom of the page. Okay, so if we start with just any old antiderivative capital F of x of little f of x, then we give the name to this capital F of x plus c that we did above. It's called the most general antiderivative. Okay, and there's a notation for it. We're going to use the same integral notation. So integral of f of x dx is going to be a way of representing that most general antiderivative. Notice what's different about that integral from the type that we talked about before is it doesn't have any limits on it. There's no integral from a to b. So we call this an indefinite integral because of the fact that it's missing its limits, and it's just a way of talking about general antiderivatives. Okay, so to just kind of summarize this discussion, this is really just about notation and terminology, what we're talking about here. The definite versus the indefinite integral. A definite integral where you have limits, that's about finding area somehow, and the result is always a number. Whereas if you talk about the indefinite integral that we just mentioned above, this represents a collection of functions, the most general antiderivative. Okay, so just to give you a couple of quick examples of this notation. If I asked you to calculate the indefinite integral of x to the fourth dx, that's just like asking you, what is the most general antiderivative? So you'd ask yourself, what is an antiderivative of x to the fourth? The power rule tells us it would be x to the fifth plus over 5, and you would tack on a plus c to turn it into a general antiderivative. Now contrast that to a definite integral. If I asked you, on the other hand, to calculate the integral from 0 to 1 of x to the fourth dx, that calculation would start the same way. You'd get an antiderivative, but then you'd have to plug in your limits, and you'd actually get a number that represents the area under that curve. Okay, let's do one more example of an indefinite integral just to make sure you're comfortable with this notation. What if we wanted the indefinite integral of 1 minus the cube root of x? Okay, well, we could maybe rewrite that as 1 minus x to the 1/3. And all we're after here is most general antiderivative. So an antiderivative for 1 would be x, and then we'd use the power rule on x to the 1/3. So we'd have to take that 1/3 power, add 1 to it. That's going to give us an x to the 4/3 over 4/3. And to turn it into a general antiderivative, we'll just tack a plus c on the end. Okay, and if we like, we could simplify that by noting that if you divide by 4/3, that's like multiplying by 3/4. So maybe a nicer way to write that answer would be like this. Okay, and again, our answer is just the most general antiderivative.